All right, Steve, I think everybody knows who you are, so we don't have to introduce you, but you could tell us a little bit about the talk before it begins.
The talk is basically something that I've noticed just writing decode over many, many years of how you spend time when you're shaping your APIs, that the decompiler has such great tools to model the data that you want to pass back and forth between things with UDAs and structs and everything. If you kind of go full bore into that, if you try to use those features, the code actually ends up looking pretty darn nice. The things that I'm showing in there are basically sometimes I'm comparing to an existing project and what it might look like if we used a more model-based API than the other way. And sometimes I'm just showing off like code that I'd either dreamed up in case like 5 or 6 years ago and never actually implemented until this talk to see what it would be like. Or stuff that one of my projects I've been working on for like 4 years, I think, that I use in my one of my day jobs. It's pretty interesting how nice the code can look and how much the compiler can do for you if you give it the right tools.
Has this topic been on your mind? I mean, I know a couple of these projects are older projects, but I mean, has this been on your mind as a concept, as a topic for a while? I mean, I know you were.
I'm a big fan of it. I think for the last, I want to say like 3 years, I've been dealing with projects that don't use this concept and probably should. And when I wrote the IO pipe library, for instance, I rewrote that API 3 times, I think, because that's just the way I am. I'll take a project, I'll work through it, say, okay, this is what I want to do. And then I get it done and I'm like, okay, it's working and I hate it. So I'm going to have to throw it all out and start over again. I always like to have the API being really nice to use and easy to understand. So that's like one of my things that just bugs me. I'm always looking for better ways to represent an API. This is kind of where that led. And I figure I accumulated enough of that baggage that I could make a talk out of it.
I remember we used to have modeling power as one of the selling points on the homepage. I don't think it's something people talk about so much, the users. At least I don't see conversations about our modeling power. So anyway, I think this is a good talk to introduce some of these concepts to people who don't know deep, particularly people who do know deep, but don't know how to take advantage of some of the things you show. And I think it ties in pretty well actually with Attila's talk from yesterday.
Yeah, it's very similar to that kind of stuff.
So you start off with the basics, with the interfaces and the classes. I can't remember if we've talked about this before. You had C# in your background, right? Not Java.
I've done both.
Okay.
I've done more C# than Java. One of my previous jobs, the server was built out of C# and I used .NET remoting and it was really fabulous. Mm-hmm. I still, the generics are just nothing like templates. So I don't prefer it. This was all before async await and all those other things. If I go back and look at that, it's awful to me, that async await API. But yeah, I did a decent project in Java, but mostly it was C# or D or C++.
Okay, I'm curious because I have a pretty good background in Java, but I don't know, my knowledge of C# is superficial. And I ask that because if you are coming to D from Java, it's natural to reach for interfaces and classes right off the bat. But then the first thing, but then the first thing you run into is that you have destructors in these classes, and you might think, oh, this is different, and you're not going to be aware of how to use them. But if you come from C++, you're going to expect to use the destructors, and they don't work out as you expect. C# has destructors in their classes or finalizers.
Mike, it's been like 13 years since I really used C#, so I don't remember.
All right. So you call this the original?
Yeah, because the interface is the original modeling system. Because basically, you have an interface. It's like, this is the thing. Here's the things it can do.
Yeah.
So.
Well, I was struck. I was struck because you didn't list destructors on your list of disadvantages here, and to me, that's a big disadvantage.
Destructors are still there. Oh, for interfaces.
Yeah, because you have to apply them to a class, and your class is going to have a destructor. So, I mean, if you're not using the destructor, it's no big deal. It's not a problem. But as soon as you start using it, there's a whole world of pain.
So when you have a destructor in a class, most people don't really know what to use it for, and it has a specific use, and you almost never should use it. But the specific use is if you have resources that you allocated that aren't GC allocated resources, then you have to clean those up in the destructor. So if you have, let's say, C allocated memory, that's a really good target for saying, okay, I'm going to clean this up. This I own this now. The GC isn't going to clean this up for me, so I have to do it. But you can also use it for, let's say, closing files or sockets or whatever. Now, you probably shouldn't rely on that as the thing that cleans it up. You should clean it up before your class goes away. But it's good to have it there as a last resort. And in fact, my first real D project that I used at work was like a little agent that I would run on remote systems to initialize them. It worked on Linux and Windows and everything using Tango. And I relied completely on the GC to clean up all my files, sockets, everything. And it worked fine, really wasn't a huge problem. But of course, those resources are a lot more limited. So you do want to clean them up a little bit quicker.
Yeah, well, I mean, interfaces and classes is just such a natural fit for Java programmers. But if you don't have the C++ background, then you're not going to know what a destructor is. But you're going to think, when you do find out about it, you're going to think it's like C++. And
it's more like a Java finalizer than it
exactly.
is
and
a destructor.
Finalizers are verboten in Java these days. You're not supposed to use them anymore.
I don't know.
Yeah,
I would assume it's the similar thing that you have for Ds, like for cleaning up things that aren't Java allocated. Like if you have a Java class that is a wrapper for, a JNI socket or something like that, you got to clean it up there. And that's what that's for.
We got a kind of a compliment here from Adam. The code font in your slides actually looks kind of okay. I usually hate fonts.
I spent a lot of time working on that font. So an Apple Keynote, which is what this is, if you copy and paste from your console window to the Keynote, it copies the syntax highlighting. So that's what I would do, is write my code in a VIM editor on the console, then select it, copy and paste it, and it'll copy and paste highlights and stuff too. So it's pretty nice to be able to do it that way. I think in a future talk I might actually write some code to do the presentation, but this time I just wanted to get it done.
I did my London talk in a vector graphics program. So
oh, nice.
I was trying to learn how to use it more efficiently, and that was a good way to get into it. I was the duck typing. That was the next thing after the classes and interfaces. Now, this seems like something that would be a good way to teach children. This seems like a good concept for your students to learn. Have you taught them anything about that yet? There's
one big barrier for my class, and that is that we're only meeting once every 2 weeks. So there's not much I can. There's two things. We're meeting once every 2 weeks, and the other thing is that this is more of a exploration. Like, it's not like a real rigid school class, that you would say, okay, we're going to do tests and homework assignments and stuff like that. We did do some homework assignments, but most of it was all optional. It was like, here's some things you can do in the meantime between our 2 weeks, but most of the kids don't do it. So, so like what I'm trying to do is just introduce them to concepts, and I'm consistently would introduce them to a concept. And as I was explaining it, I had my notes. I'm going to go through this, 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 and this. And I would get probably about 25% of the way through what I thought I was going to talk about, because they would just have so many questions. So I don't think they're at the level yet to talk about complex typing and things like that.
Oh, it seems like it's a less complex thing, I think. And the idea that if it quacks like a duck, or looks like a duck, I mean, it's such a good concept to get across. But I know what you mean. Yeah.
The only thing is, now we're talking about templates.
Oh, wow. Fun.
If you're dealing with duck typing, you're dealing with templates.
Yeah, that's true. That's true.
So I didn't want to go there.
Yeah.
All of my code is simple structs and stuff like that I show them.
If I'm watching this video on YouTube somewhere down the road and I haven't seen your talk yet, how would you summarize your Strawman Structs library to me?
All it is it's obviously a proof of concept. I literally just wrote it for this talk, but it basically allows you to provide a model to then do your template constraints with. So instead of, you see the left side here, it's all like, oh, does this work? Does that work? That's just a bunch of stuff, that to try and then reconstruct, oh, what does this type actually look like? Whereas on the right side, it's just like,
clean.
That's the thing, I can read it immediately. It doesn't matter that the code underneath is really complex to generate all those little things over there. It's kind of like you don't think about your, you can, but you don't always think about, what is my code generating in the exact assembly?
Mhm.
Like, I don't care. I know what it's supposed to do by reading the D source code. I don't need to read the generated assembly to prove that to myself. So that's the kind of idea, is like your model is like your high level code, and then the individual checks or the low level things.
Since you recorded the talk, have you thought about how you're going to handle infinite ranges?
Not completely. So an infinite range is something that has empty as an enum. So it's compile time always true. And I could invent some mechanism to say that. But the thing that was really tricky was the random access range could be an infinite range, or it
Yeah.
could be a bidirectional range.
Yeah, that's
And
what I'm talking about.
That's two different API pieces that have to be correlated. Like it either has length or it doesn't have length, and it's an infinite range. It was kind of like these two checks that have to go together, and I'm not sure how I would couple those together. But I mean, obviously I could come up with something. The thing is, you have all the power you want. I can create a dummy type that then signals to the Strawman library, oh, this is what this means. This is grouped with this other thing. So you can see that with the any type. I could say the type this thing returns is also the same type as should be in this function parameter. I don't know what it is, but it's got a match, and that's how that works.
I haven't looked at the code yet.
Well, the code is really gnarly.
Yeah, I was gonna ask how it looks on the inside.
It does work though.
Yeah.
But like that Boston D meetup talk I gave like 5 or 6 years ago was just an idea I had. And then I was like, I want to try and implement that, because that was kind of like a modeling thing, and see how it would actually work. I just got it working so I could make the slides. It wasn't like intended to be like, oh, go and use this library now. So yeah, it needs a lot of polish, but I mean, the concept is solid, I think.
Yeah, and I notice you're at the core implementing it with mixins. Are you using mixins extensively in your decode?
Yes. When you're doing compile time introspection, you have to use mixins, because there's a lot of stuff that comes back as strings, and they're actually a lot of times easier to work with. So one thing that's great about a string mixin is you can use all the string manipulation functions you want to generate your code. If you're just handed an alias, it's not as easy. Now you have to deal with templates necessarily.
Well, where I wanted to
functions.
Where I intended to go with that question is, I mean, everybody's going to use mixins to some degree when they're metaprogramming, but are you using them extensively in your decode? I mean, to the degree that you find you have to debug them. We had this conversation yesterday in the chat.
I know what you're saying.
Yeah. So have you reached that point yet, or are you still just using them?
When I use them, I use them as sparingly as possible. I love the new feature too, that mixin can be an expression instead of having to be a statement. I think that's not that new anymore, but that makes it really nice, because you can put more of your code as actual code instead of having to build this giant mixin. There's also, you can now mix in types, which is great. I want to do the least amount of stuff with a string mixin if I can help it. There's some other tricks you can do, like declaring an alias for a type and then using that alias inside the mixin instead of trying to name the thing that's coming in. That helps a lot. You try to make your mixin code as simple as possible, because like you said, it's almost impossible to debug. But like, if you want to look at a library that uses extensively string mixins, but also provides a decent debugging experience, you look at vibe diet templates, because they basically take a completely different language and convert it to D.
Right.
But then if you have errors in that generate bad decode, instead of pointing you back at the mixin code, it actually points you back at your source code in your diet template, which is kind of cool. There's ways to make the mixins friendlier to debugging, but it's not perfect.
This GitOp2 library is something else you developed for this talk, yeah?
Yeah.
To use the Strawman, yeah. And you say it's a whip, and I was going to ask you if you have any plans to go anywhere with this, but then I see your commit message here is a commit for posterity. So that that doesn't sound like it's going anywhere. Are you planning?
No, I think that I might release that. That was a cool little project, and I was surprised at how easy it was. If you look at the code, it's super simple, and it's easy because I can just wrap GetOpt. If I was going to do it for a permanent thing, maybe I would rewrite what GetOpt does instead of like just forwarding the call there.
Attila said yesterday that something like mirror, the goal would be to get it into the library at some point, so that we would have painless metaprogramming in the library. Would you like to see something like your Strawman stuff in Phobos, or does it belong outside as a third party?
So there's always a cost, and I don't really talk about the cost in this talk, but other people have talked about it. But whenever you're doing lots of fancy mixins and templates, there's always a cost to doing that in compile time. And I am not sure how much compile time, like using a Strawman Struct, would add to the compile time versus just using the individual things. So that's something that would concern me about just putting it into Phobos and having it just go to town. I mean, we recently had a guy on the forums, or I guess he wrote a blog post that was identified in the forums, where he's converting his D game to Jive because it just takes too long to compile.
Yeah, I saw that.
Really just from all the incremental templates usage. And, it gets to the point where it's like, okay, well, I've already designed my code to use all these templates and have all this stuff in here. If I want to make it faster to compile, I have to rip everything out and redesign it. It sucks. So, I mean, I really think a good answer is we just need to make templates faster, or need to make introspection capabilities like that mirror library to make that faster. And I think a better CTFE engine would be a huge help there.
Adam says the only time you have to use mixin is to generate new identifiers.
Yes, you can use the traits get identifier, traits get member, and all that stuff. And sometimes that's okay. Sometimes it's like in the getOpt example. I didn't show it on the slides, but I'm basically creating a giant mixin to call getOpt with the right values, and generating a list of arguments is not something you can do at compile time. You have to generate a mixin and then call it that way. There's places where you have to use it, but like I said, I like to not use it as much. And at the same time, because we're using strings, you can use CTFE and just write a normal function. That's really, really nice. And providing a better way to just write a normal function, like with the mirror thing, or with some other feature, like maybe the type functions or whatever, I don't know, that would be really useful in reducing the amount of weird template code you got to write.
There's a comment here from Spoofer. Once projects get to a certain size, we should embrace object files and traditional incremental compilation. It's convenient to build everything all the time, but not the only way.
Yeah, I think that you can do that to a certain degree, but you also can't do that when you're using templates today, because if you're using a lot of templates and templates are not in that object file, you need to generate them for the new compilation. So, if you have for instance, some data structure, a list, linked list, right? S list in Phobos. If you have an S list of int, maybe that's already in Phobos in the object in the library file, fine. But if you have an S list of your specific type, that's not going to be in there. So you need to generate that as well. One thing I would say is if you use Dub, you're already kind of getting a lot of that for free, because it's already building the library separately that you depend on. But yeah, splitting it up into different object files, it would be a benefit. And I think Adam had a great idea on his blog on packaging the object files with the already compiled templates or the already processed templates as a separate piece that then you would avoid some of these weird linker errors, because avoiding linker errors is always a nice thing. Linker errors are just like, I think Andre in his book says, it's encrypted Klingon. So it tells you the errors.
Years ago, when I first saw opDispatch, I thought it was like one of the most awesome things ever, and never had a need for it in the stuff that I do. Does that show up in your code at all? How often do you use it?
Oh yeah, I've used it extensively in the SQL builder. Everything is an opdis. There's literally in the data set type, there's two functions. And they're both opDispatch.
Does it work as advertised?
Oh yeah, no, it's great, because what you're doing is you're creating a type based on the original model, but your original model just kind of driving how your new type works. And using opDispatch, you can just generate the functions that are used. You don't have to generate all of them. Like I think I don't know if it's already gone past. I think so, but yeah, the black hole and white hole, you're generating a class based on an interface, but you have to generate all those functions that you even if you don't use them. With opDispatch, you only have to generate the ones that are used. It's a pretty nice feature.
Yeah, so it's solid, and you haven't seen any corner cases or.
Oh, one thing that does stink about opDispatch.
Okay, here we go.
And this is really a more connected to the design of the compiler. Is if you have an opDispatch member in your struct, it will try that opDispatch, and if that opDispatch fails to compile it pretends that it's not there. So if you put a bug into your opDispatch by accident, like maybe you forgot to import something or whatever, it doesn't even try to call it, even if it would match the function parameters that you're giving it. And so that can lead to some very weird errors, like maybe it tries to call some other function somewhere else because, opDispatch didn't compile. So maybe I'm going to look out for a UFCS function. And that can get really annoying. And plus, it also overrides things it shouldn't override because of that. And these are problems that have been tried to be fixed in, I think Razvan has tried to fix somebody else tried it a while ago. But it's really hard to do it because the way the compiler treats compiler errors. I mean, this is not something that I know because I don't know the compiler very well, but I've read the comments and they say that this is just too hard to do because of the design of how the errors are gagged and treated. So it's unfortunate.
Adam says opDispatch rocks, but you do have to be careful with it so you don't accidentally trigger duck typing.
Yes, you have to use liberal template constraints. You don't want to leave it up to the body of the opDispatch not building. You want to kind of have a template constraint that says, I don't want to override this function. Let it go to the UFCS function if this, if it exists.
So in your experiments with this, with putting this together and testing it out, any bumps in the road stand out to you?
The GitOps I wrote in like a day. That just almost wrote itself. It was really nice. And one thing I did forget to mention on the GitOps, there's a guy who wrote a similar type of library written from scratch. I think it's called argparser. It's in the code. You should check that out. It does basically everything that my GitOps 2 does, but it's just got way more features, and it doesn't depend on GitOps. So I do like that library. I would recommend it, but I meant to mention that, but I forgot. But the Strawman, I struggled a lot with. At first, I was like building it. I was like, I can't make this work. And then I just stepped away from it for a bit and came back and was like, oh, this is dumb. All I have to do is take this model and build what I would have written as template constraints. And then it was easy.
Did you go running?
I wish I could run. I used to run when I was younger, but I don't know, something about my knees. If I run for too long, my knees start hurting. And I can do like biking or elliptical or something like that, but I can't do the running.
Are you going to pursue this further? I mean, in the immediate future, or are you putting this aside for a while to work on something else? What are the...
Which part?
The Strawman.
Strawman. I wasn't intending on pursuing it unless people are interested in seeing that done. I have a lot of other projects I want to get finished. For me, it was just a toy thing to demonstrate something, and it certainly could be turned into something more robust. I think it's something that people might like. People might like to use that.
Yeah, I think I like what it does, but I'm curious. I mean, I'm looking at this in one way. You know, we're presenting this stuff as like, this is awesome. This is, you know, these modeling power. It's really cool stuff. It is cool.
Yeah.
And you know, you got Attila's mirror, but then you stop and you think, okay, we've got both of these talks at the same time. That means there's some kind of demand for this, and you know, everybody's looking at it. So what does that say about these metaprogramming? We all talk about how great these metaprogramming is, but what is it about it that we need to come up with these simplified interfaces to put on top of it? And why don't we have them there already? I mean, is there a message here that we need to do something, to change something, or is the message that it's working as intended because it allows us to do these things? How do you see this?
So I see it in a few ways. Like you said, one of the things that seems to happen is, and I talked about this in my 2019 talk, is that everyone ends up writing a serializer in D because it's made for that.
Well, I've never written a serializer in D, but okay, go ahead.
Yeah. It's so easy to do that you end up doing it instead of having to rely on somebody who wrote this really complex, you know, fancy piece of code. It's like you just do a for each loop over the members and you're done. It's that kind of thing where it's like, it's almost trivial, so that it's like, do I really need to make a library for this? You know, that's one piece of it. So I think that's why we always have all these new things that are the same as the other things that other people have written, you know, that basically accomplish the same thing, but in a slightly different way, because it's like, oh, I could just do this and I don't need to look for something else. On the other hand, there are some pieces that, you know, the language could be better with. If there was a way to interface with the compiler to say, make it look like this, like a C++ concepts type of thing, that would be something I think people would use and find value from. Template constraints is one of those things where, like, for instance, I tell my students, you know, here's this function, write line. This is how you output stuff to the screen. I don't want them looking at the signature for write line in the documentation. It's just they will never understand what's going on there, because there's just so much stuff with template constraints and different character types and UFCS. There's just so much stuff. I'd rather just tell them, call this to write stuff to the screen, and you're done. You don't have to think about it. But to making the template constraints more approachable like that, it would be a huge benefit, at least to the documentation. Like another thing that I didn't really talk about with Strawman Structs is you can document that model. And there you go. There's your document that says, you can go right into DDoc. Here's what a range looks like.
Is there a future DIP authored by Steve Schveighoffer on for Struct Lambdas? I guess we could call them anonymous structs.
No, probably not. I'm the type of person who likes to throw stuff, over the wall at the compiler developers and
let somebody else catch it and run with it.
I'm not making those dips, because I leave that to like Timon and Paul and Walter and all them to figure that out, because I'm just a poor user that says, oh, what if we could do this? That would be cool. And then they come and say, no, it'd be bad because XYZ. I'm like, yeah, you're probably right.
I have one more question related to the Struct Lambda thing. I mean, that's a wish list item that's appropriate for the talk because it was on topic. But what else is on your list? Things you'd like to see that we don't have in addition to the Struct Lambda?
Yeah. String interpolation.
Yeah.
Please. Okay. String interpolation would be amazing. I did mention in my talk as well. And I was happy to see TIIMECODES in that as well. So I would love to see that happen, especially I'm really excited about the possibility of not just making a string, but generating an argument tuple that you could then use for things like my SQL builder would be fantastic for that.
Adam says the yet another interpolation dip. Yeah, might not be formally written, but the ideas are all solid, and we should just dispense with the formal drafting and write the code.
Well, Adam already wrote the code. He already made changes to the compiler so we could try out our dip that came before it. The part that he didn't do, that when we had our dip that we were proposing, one of the big things that was controversial was that if you used it as a string, it would automatically convert to a string. That was the only part he didn't write, and that's not even in the UA dip. So it's already there. I don't think it was even that much code.
Ricky says we should support tuples with UDAs because that is a great use case.
Yeah, I agree. I mean, if we got actual language defined tuples, it might be essentially just a struct underneath. I don't know. It could be something where you have a struct with tuples. The other thing with UDAs, and you see this on enums too, is you can put a UDA on an enum, but because it's not a declaration list, you can't do things like, I want to assign this UDA to this batch of enum members. So if you have something that's an expression more than a declaration block, then UDAs aren't as nice. You have to repeat them everywhere for everything. It gets a little bit tedious.
How long did it take you to get all this done to put the talk together?
So I'd say, like I said, writing the code for the get op 2 took me about a day. That was fun. Writing the code for the Strawman took me a few days, and mostly just struggling to figure out the right design for it. My SQL builders, like I said, it's been there for a while.
Right. How long have you been maintaining that? How many years?
It's been like 4 years. It's not published on code.dlang.org, but it is published. I had it private for a long time. It was basically for my company. I use it internally, but I do want to eventually publish it. I just haven't fully documented it, which is something I like to do before I put something out there. So that didn't take me too long, just writing some examples or taking the existing examples that I have in the unit tests. The thing that took me the longest was editing the video.
But
I want to say, I'm not joking, like 10 or 15 hours to deal with the video. Setting it all up. It's such a pain in the butt.
You start doing enough of them and you get more efficient at it, and then you upgrade your editor to an editor that you didn't understand a year ago, and now it gets faster, but it's still time consuming. And I said this to you in an email, and I will repeat it. Yeah. Thank you for editing your video.
Well, I didn't want some of the crap that I edited out going through, because I just did it all in one take.
Yeah.
I just recorded the whole thing in one take, and if I messed up or stumbled or stuttered,
you fix it in post.
I'll just jump back and do it again. And then I had a bunch of problems with the green screen, because I've never done the green screen before. Had to look up how to get that to work. I want to give kudos to Mike Shaw too. He puts out a lot of videos with the green screen, and You must have a studio or something that you guys do. That was definitely the difficult part.
Mike says over the last year, his video editing process has gotten quite streamlined. When are you going to write a book?
Oh boy. Another thing that sounds like it's going to be a lot of work. You wrote a book.
Yes, I
I
did.
remember your book. It was a good book.
That was
Yeah, that's not something on my horizon for sure. I would like to do more YouTube videos. That's something I really want to get into.
Yeah, we have a question. Great use of user-defined attributes, e.g. required. Any other attributes you use? Anything for static analysis?
Anytime I have something that I want to affect the way that a serializer works, or that, you're basically talking to your library through the compiler. You're telling your library, this is this other special way I want you to handle this thing. It's not like a normal field member. I want you to treat it this way. So, for instance, in the SQL builder, if you have a column name that either can't be represented in D because it's a keyword or something, or you have it, you want to call it something different in your code, which, I had a case like that. Then there's a UDA that says, okay, really just call it, the column name in the database is this, but I want to use it directly as this other name. Or if the type is different, like in one case in my SQL builder, I had an existing database, which was built on, using PHP. And one of the legacy things is an active or inactive flag was the guy stored as a character, or one character string. It was either A for active or I for inactive. Like, I don't know, just weird. So I wanted that to come out as a Boolean. So I created a type that parses the A or I and creates a Boolean, or takes a Boolean and spits out an A or an I on the way back. So there's different ways to do those things, but I've played around with a lot of stuff, different ways to do those things. That's the other thing about D. It's such a wealth of possibilities. You almost don't know what to pick. I use UDAs all the time. It's one of the best features of D, especially when you're doing modeling.
Spoofer asks, what kinds of things would you like the most help with, or that the D community needs help with?
I think the D community needs more polished tools or tutorials, or like, I feel like people come to D and they find this language and it's amazing, and they're used to something else in a different language, and that thing just doesn't exist, and they're not going to build it. They're going to say, okay, well, maybe I don't need that thing. And they work on stuff for a while, and then they just lose interest because it's not.
That was my DConf talk.
Whether it's an IDE or certain kinds of tools, debuggers, like the debugging situation in VS Code and on Windows is just horrendous. Like I can't even use it with my kids, because if you look at a string, it's just going to show you a pointer and a length. They're not going to know what that means. Those are the kinds of things that I think would really help D adoption.
Well, one thing that I've had my eyes opened to, and I mean very recently, is that, in the past, I've always looked at contributions from the community. Where do we need people to contribute? Where should we direct volunteers? If somebody says, I want to help, then, hey, go do this, go do that. But I think I've kind of had my eyes opened that that's really not an efficient thing to do. It's not the best use of anyone's time or skill set. And what you do is, when somebody says, I want to help, what can I do? You say, what do you want to do? And say, go do it. We've got a lot of things that need doing, but nobody's going to do what needs doing unless they really want to do it. The people who want to do it are the ones who are going to stick through to the end. And so I have dreams, I have goals to see about how we can bring this stuff into action from next year. So what the community needs help with is getting people motivated to contribute to the projects and the repositories that excite them, the ones they're eager to use, the ones they want to see work when they're not working. So I think that's what we need help with. I don't want to go into a long spiel about this. I'm sorry. Yeah, the hard part is keeping people motivated and keeping them following through to the end. But yeah, I just let us know. Come to a meeting, come to a foundation meeting. Email me, email Razvan. Let us know what you're interested in and how you'd like to help, and we can find things that fit your interests and your skill sets. I think that's the way.
I think also, like, like one of the best things you can do is learn more D.
Mm.
Like if you're coming in and you're like, okay, what can I do to help? I don't know much. Like learn more D so you can kind of understand some of this other stuff. And that's one of the things, like one of the reasons I want to make a YouTube series on this is, and Mike's doing a good job of this too, Mike Shaw, but there's a lot of tutorials on, oh, you know C, this is how you do this in D. You know Java, this is how you do this in D. You know Rust, you know Python, whatever. Maybe not Rust. There's many things where it's like, if you know this thing, here's how you would do the same thing in D. But there's not a lot of tutorials is, oh, you don't know anything about programming? Here's how you program. But we're going to use D to do that. And I really think D is a great language for learning because you can have what I call like basic D or simple D. You know, you don't have to deal with memory management. You know, arrays are just there. Everything's there. And you just learn that part of programming. And then as you need more, you know, functionality, features, or you want to learn about classes, or you want to learn about templates, whatever, the feature is there. You just add it in. So I think that would be great.
And Steve, any closing thoughts before we go?
As always, you know, D rocks. I really, you know, the biggest thing I hope people take away from the talk is to open their eyes as to like what types of things you can do with the compiler. The decompiler is super powerful, and enlisting it to write your code for you is like one of the best things you can do. To say, here's what I want, just go do it. And your library that you use to write that code is going to be useful over and over and over again. I can't say enough how awesome it's been to like the SQL builder just say, oh, I'm gonna make my struct, here's my data table, and then everything works. I don't have to do any other fancy code stuff. It's all done for me already. And so yeah, go use that feature of D and see how it works for you.
All right, we're into the break. It's going to be about a 15-minute break this time.